Chemical equilibrium is a pretty intimidating topic, and as scary as it is to think, this is only the beginning of the madness of chemistry. But fear not, because I know you and I are going to make it together. Concepts of chemical equilibrium, I feel it is best to start with a simple example such as this. In this scenario, I'm creating a puddle by pouring water in it. Meanwhile, my brother is pouring the water out. So, as I'm pouring in water, the size of the puddle would increase, whereas as my brother takes out the water, the size of the puddle decreases. If we repeat the cycle 100 times right here, you would actually see no observable change. You would still see the same amount of water after a period of time. In this case, the rate of me pouring in water is going to be equal to the rate of my brother pouring out the water. Hence, this puddle has reached an equilibrium. So we can sort of build off of this topic and create a definition for ourselves. By definition, chemical equilibrium is the point at which the concentrations of the reactants and the products are both the same. You should also understand that there is a forward and a backward reaction in chemical equilibrium, which is represented by this reversible reaction symbol right here. Let me give you another example. Let's just say that AB plus CD is reversible reaction to WX plus YZ. In this case, AB plus CD would be able to transfer its energy to this side, whereas the products would also be able to transfer its energy to the reactants. Any further ado, let's head on to the most exciting phase of the chemical equilibrium unit, and by that we're going to tell us what concentration all of the reactants and products will be after a certain period of time if it undergoes equilibrium. And so let's just look at the graph or the reversible reaction for ammonia right here. You will notice that the concentration is the same at one point. The lines are all parallel to each other, and this just simply means that at any point after it is a straight line, after it is a parallel line, the concentrations will be equal to each other. For finding the K constant is the concentration of the products raised to a coefficient and the reactants raised to a certain coefficient. So, and also after this, you would also find out which direction each one will be. If the K constant just by itself, if you were not given a before or after Q value, then if the K value is greater than 1 right here, you would find out that the reaction would favor the products over the reactants. So that's where most of the reaction would occur. And right here, we will find out that if the K constant is less than 1, is less than the value of 1, we would find out that it would favor the reactants. And so there it is. So ammonia is formed by the reaction of nitrogen and hydrogen, as we can see in the reversible reaction above the graph. And when you're asked to find the K constant, how would you do it? Well, if you were given a set of concentrations right here, and for those of you who do not know what the meaning of molarity is just a concentration of any aqueous solution. Basically, it is calculated by the number of moles over the amount of liters. And if you remember the formula, so this is what it would look like. And if you plug in these values right here, you should get a value or a concentration of 0.0602 molarity. 0.0602 is less than 1. So therefore we can say that the reaction, the reversible reaction, it would lean towards the product. So there would be more reaction on the products. Thank you. I'm Honest Perry, and I'm presenting you Chemical Equilibrium.